Okay, adding and subtracting polynomials. Basically, a section about combining like terms. We did it plenty first semester in our algebra course. Kind of just getting back to it and reminding you what it was all about. If you're going to be combining like terms, those terms have to have the exact same variables and the exact same exponents. You can't add or subtract them unless that's true. We've talked about you can multiply anything together regardless of how similar they appear. Different exponents, different variables. You can do multiplications, you can do divisions, but if you're going to add or subtract things, they have to be considered what we call like terms. Okay, to go from here, just a couple of reminders for terminology. We're going to take this trinomial, has 3 pieces, and add it to this trinomial. If it's an addition problem, there's absolutely no need for the parentheses whatsoever. The book has them, is the only reason why I have them in our little set of notes here. Okay, but they have no meaning, so you can scribble them out, pretend like you don't even see them. It's just an expression that has 6 terms in it, and we're adding each piece together. Pay attention to signs, and combine anything that's considered like terms. So I just like to move from left to right. I look at it, I see a 3x squared. So I look for any other piece in my entire problem, any other term that has an x squared in it. So you look around, you see an x squared right there. So what is 3x squared plus 4x squared? Well, it is 7x squared. So when you're adding or subtracting things, when you're combining like terms, all you do is change their coefficient. Add or subtract their coefficients. Exponents stay the same. The variable and the exponents, they're not even affected. I combine those. I just move to the next spot in my problem. This has an x to the first, and we have an x to the first right here as well. So I'm just going to combine their coefficients. This is 20. I'm going to add to it a negative 1. So 20 plus negative 1 is 19, and the variable and exponent attached to that doesn't change. 19x to the first power. With no variable attached, remember these are called constants. So the constant 5 and 2, add them together, of course, you know that's 7. Don't have to explain that. Not every single term will be able to combine with something else in each problem. Sometimes if it can't be combined, you just got to rewrite it in your answer. We'll see that below here. So continue to look. Do they have the same variables? Do they have the same exponents? That's how you know you can add or subtract them. That's what this section's all about. I only have the 3 examples, so you saw one. We got 2 more. Okay, this is a trinomial, and we're going to subtract from it another trinomial. So we're subtracting everything you see in the second set of parentheses. In order to prevent errors, maybe a different color pen so it shows up a little better, we're going to think about adding opposites. Sometimes you guys don't think subtractions, adding opposites. When we first learned that concept is just adding and subtracting, you don't think it's necessary, but to me, you're going to make errors if you don't remember that subtraction belongs to everything. So before I start the problem, I just add opposites. So I turn into an addition of a negative 5x squared, a positive 7x, and a negative 9. That subtraction sign basically changes every sign in the second set of parentheses. The other way you can think of that getting accomplished is put an invisible 1 behind that subtraction sign. It's like you're doing the distributive property with a negative 1. Okay, once you've done that, it's exactly like the problem above it. It's now an addition problem. The parentheses don't even have a meaning anymore. Notice how no signs were affected in front of the subtraction sign. So let's go through. Here's an 8x squared. I can combine it with these x squared. So we have 8. I'm adding to it a negative 5. So 8 plus negative 5 is 3. And I stay with an x squared, not an x to the fourth. You don't add or you don't change exponents in any way when you're adding or subtracting. I got an x to the first in this spot. I got an x to the first in this spot. They're both positive. It's a positive 6, a positive 7. Combining for a positive 13, x to the first. Put the invisible exponent 1 down if you really want it. Okay, just as long as you're careful with signs, you're going to be okay. This is a positive 1, a negative 9. You really pay attention to what signs you're working with. You add them together, you get a negative 8. Just don't try and go too fast on these problems. If you think they're easy, you're probably going to make a mistake if you try and go too quick. They can get a little more complicated. Have more than one variable in the problem. We have x's and y's in this third example I have. But before you even worry about any of that, I suggest you really take the time to add opposites. Add a negative 4, negative 6, negative 3. Change every sign. in the second set of parentheses. And then just start your problem. You have a 11x squared y, so let's look for other terms that have an x squared and the y the first in them. There's an x and a y, but their exponents don't match. Here's an x squared, y the first right here, and that's the only one in each problem. So you're going to combine your 11, your negative 4, for 7x squared, y to the first. Just add their coefficients together. I have a negative 9, x first, y to the first. There's no other term in this entire thing that has an x to the first and a y to the first in it. So it just has to be rewritten. It can't be combined with anything because it has different exponents and different variables from everything else. I have a 5y. There's no other y here, but we got one on the end. Almost went right past me. So we're going to add a 5 and a negative 3, come up with a 2y. Those other exponents, the invisible 1 stays in invisible 1. And the only term I've not dealt with is the negative 6xy to the second power. Yeah, we had an announcement come on the overhead there. There's no other term that matches it, so I'm just going to rewrite it in my answer. And in the last section, we talked about ordering things to try and match up what their book's going to be. You're most likely to see most book answers that I'm going to display while we're grading in descending powers of x. This is an x squared, x the first. This one also has an x the first, so they really tie. The book can put them in any order, and this really has an x to the 0 power. So you might see it written last, but we're not going to take off any points while grading for having things in a different order. As long as you have each individual term, its coefficient, its sign, and all the exponents the same, we're going to be okay. The order is not going to matter too much to us. So we can just keep this as our answer. If we desperately wanted to reorder it, we could.